Welcome to Arduino Sensors. Today we're going to take a look at the magnetic read sensor. Now I have two of them here. This one here is on a board, so you get a digital output or an analog, which is kind of a waste because for most applications you can go with just the one. This is on a breakout board. This is just the read switch on a breakout board, where this one here, it converts everything to digital. And what it is when there's no magnetic field present, the digital pin is high. When a magnetic field is, oh, excuse me there, when a magnetic field is introduced to it, the switch goes low. Simple. Now with this one, when there's nothing going through, nothing's connected, because a read switch is just two reads. And when the magnetic field is introduced, it just makes the two reads stick to each other. The magnetism affects them and makes them stick. So this one, the pins, your output would be low, but when you put your magnetic field into it, it would turn the allow current to flow through it. The only real benefit to this one I would see is beams when there's a magnetic field present. The pin is low. You could use this to make your own alarm for like windows and doors. You'd have a magnet on like the window, and then on the frame you would have the read sensor, so if the window was opened, it would set an alarm off. And you wouldn't even need an Arduino. I mean, you'd have it just connected to some kind of alarm using a transistor. But I'll leave that to you if you're interested in it. But I'll demonstrate it here real quick with an Arduino board. Connected. We need some power. And after I show you this one, then we'll go ahead and take a look at using this one as well. There we go. Now I have it here. I just got the LED on. And when a magnetic field is introduced, it makes the digital pin go low. And the Arduino is reading it. It's telling the LED to turn off. You could reverse that and have it the LED off and then turn on when magnetic field comes in close to it. But if you're using this with Arduino, I mean, a real common thing would be making like a door or window alarm with it. And I'm sure you've seen these sensors before, but they're encased. Here's a quick picture of them. These are the ones that you'd normally commercially buy to put on your windows and doors. I'm sure you've all seen them. All right. If you'd like to see the sketch for this, I'm not going to go through it. We're just doing a digital read of the output on this board. Just look in the description below. I'll put a copy of the sketch down here. So if you want to try it out yourself, you can. I'm going to set this out of the way. To demonstrate the other one, I'm not going to use the Arduino. I'm just going to put it on this little breakout, on this little breadboard here. I've got my 5-volt power supply. But you just connect this one to Arduino. Instead of having there's a positive and ground pin on this sensor, and it's right here. This is digital, this is positive, this is ground, and this is analog. I don't know why really they put this on here, except for the digital thing. Like I was saying, you could use this as a standalone to trigger an alarm without using it in Arduino. That's about the only benefit to this. Otherwise, this one, the middle pin is not used, and the outer two pins, doesn't matter which way you hook them up. I mean, this pin goes to this side of the switch. This pin goes to this side. Now I have a little circuit here set up. I've got an LED, and I've got a current limiting resistor, and that goes to this side of the read switch. And to the other side of the read switch, I got 5 volts coming in off my little power supply here. So when magnetic, oh, I didn't have it lined. There we go. So when a magnetic field is introduced, I think it's a little loose on the board. There. I think my breadboard's a little loose on me there. Sorry about that. There we go. When the magnetic field is introduced, it's closing the read switch and it's turning the LED on. When it's removed, it's turning off. I think this sensor, I don't know, when it came, it was all smushed down. I think mine might not be working very good. I actually ordered some just of these read switches for further projects we'll be doing here on this channel, but I got one of the 30-some sensors in one kits to try out for doing these videos, but Yeah, this particular sensor is not working very good. Like I said, it was smushed down. I think it's malfunctioning. It's kind of working. It looks like it likes to work better when it's the magnetic field's further away. But it does work. This particular one is just, it's not functioning properly. After this video, I think I'll go ahead and just throw that one away. But that's all there is to a reed switch. It's just two little reeds, and it's sealed in an airtight in glass. And they put some gas or something in there, so pressure and stuff doesn't affect it. It's just two reeds. And when you introduce a magnetic field to one side of it, it makes it close and lets current flow through it. When you remove the magnetic field, it opens up. And the way that they go, the magnetic field, you're better from the front or the bottom of it, not to the sides. Typically, they trigger a little better if it's straight onto the top or the bottom. And that's just, where the reeds close. So if they're closing like this, this would be the top or the bottom. And this would be, the sides. So, all right. Hopefully everything made sense to you and you'll be able to use them. They're very simple. That's why this video is real short. So I'm going to go ahead and wrap it up. I'd like to thank you for joining us here today. Don't forget to share, like, and subscribe. And once again, you can look down below in the description below, and I'll have that sketch for the Arduino code if you'd like to put that together and try it yourself. And that's just, we're using the digital output on the board, goes to pin 3, and then I have it wired, the positive and negative wired up on the breadboard for the little breakout board. And then I just got an LED on digital pin 13 because it has a resistor already built in, so I didn't have to put a current limiting resistor on here. All right. Well, thanks for joining us, and I hope to see you here again.